I'd like to get, at least for this one, yes, I expect people to give me feedback on, on the topic. Yeah. Hi, everybody. So my name is Vincent Guittot. I'm working for Linaro on the kernel and the scheduler in particular. So for this talk, I'd like to discuss about how to set some latency int for CFS tasks or for other tasks that depend on how we name them. So I can say that directly. I don't have any solution so far. I mean, it's a long discussion. I think we have discussed this for the last maybe 4 years without having any conclusion. So I'd like to restart this and see how we can move forward on that. And especially so with the fact that now we have the EEVDF way of scheduling, which changed the way we are selecting the CPU on the CFS scheduler. So yeah, here is what I'm going to discuss with you. So the first one is what latency int means for a task, a non-real-time task, especially because we already have the real-time and deadline scheduler, which are some hard real-time scheduling policy. And for that, it's quite well known how we can set the latency. But for the third one, which is the others scheduling class, it's not clear, and it's clearly not the first goal of this one. So I will also give a short recap of what we did with the CFS latency discussion. And then with this new EEVDF way of working and what Peter, I don't know, Peter is in? Okay, good. Good, so yeah, because I'm pretty sure that you will have some comment on that. And then I will focus especially on the things that is sent in his last budget, which is using the slice as a way to schedule some tasks first. What are the, I would say, the advantage and the drawback on that? And then the other, that will be what would be the next step and how we can go there. So let's start with the latency int. So we have, so I would say outside this real-time, hard real-time task, even if you're not a real-time latency constraint most of the time, especially because when you're involved in the display pipeline, in some audio multimedia pipeline, or even with some I/O, when you are involved in the I/O process, I mean, you have some latency because this will impact clearly the throughput or the frame rendering. So this is the task can have some latency constraint. And what easy and usual way of working is that some tasks run before others. And before it's a quite vague notion. And especially because they have some soft deadline. I mean soft deadline because I mean every miss the deadline that will not be it's just that the quality of service will be not as good as expected, but they have an idea. And typically when you have some frame rendering, you know that your deadline, if you want to render your frame correctly, is probably, depending on the FPS, it's maybe a quarter of the FPS and something like that. So you can easily provide, say, I would like to run in the first quarter of the current frame, something like that. Some others have some latency constraints, mainly because they are the bottleneck, and especially when you're doing some I/O. The hardware will wake up the thread, and the thread will block everything. So as long as you are not scheduling this task, which usually doesn't do that much, everything will be blocked and unlocked. So you want to run that quickly, I would say, as soon as possible. But in this case, you don't have any real deadline. It's just that I'd like to run as fast as possible, as soon as possible. That's the other kind of latency that we can see in the kernel so far. Most often, we have an idea of the period for such kind of activity, it's multimedia things, and maybe not for the I/O part, but even maybe for the I/O, we have an idea of how often to do. Sometimes we have a soft deadline. I mean, I'm running every 10 milliseconds and I want to run in the first 2 milliseconds. That's what I expect. But it's quite hard usually to know how long you will run. And I would say that if you're how long you will run, how often, and the deadline, move to the deadline scheduler. I mean, if you're so sure of that, we have a deadline scheduler that fully fit with this kind of situation. So the running time is really the part that it's quite hard for the user to define. And especially if we start to make some mistake in the running time, then that will be a problem, and that will provide some junk time and things like that. On the completely opposite side, we have some tasks that doesn't care about latency at all. But what they really want is to have a long running slice without preemption. It's just that what they care about is not being preempted by other one, in order to move forward and to provide some food for the next task and so on. So, and in this case, yes, they prefer a longer slice. What they want is minimizing the number of functions. The main two tasks that I have so far, I would be interesting, is there any other meaning, any other input that you see to describe the latency of a task, the CFS task, I mean. Maybe I'm missing some, but I think that's covered almost everything that we want to solve. You want to, yeah, there is it.
Been in some discussions where people have been talking about, for pipeline tasks, they want to make sure that a certain set of tasks are spread across CPUs. So there's a lot of parallelism. Okay. So in that case, that's kind of a type of scheduling they would like out of some of these latencies.
Okay, so yeah, it's about parallelizing, but I would say in this case, if we have several tasks, either they can run in parallel, and I agree that if you provide normally the same deadline, this could be an input to say, okay, I can use 4 CPU to run all these tasks. Then if you have the deadline at 10 milli, 4 milli, 6 milli for each task, it's also maybe means that you have a kind of pipeline, so one after the other one, and in this case, you can pipe them. So, but that's a deadline in this case. I agree that's probably something we can have a situation. It's not only the task itself, but your deadline depends on the previous one as well. Yeah.
Not sure how widespread this need is, but in 2018 or 2017, really nice discussion started. It was started by an IBM employee who came, and he was describing pack or spread.
Yeah.
Pack or spread because in his power architecture, he wanted to pack the tasks to increase the clock. But personally, my view on pack or spread is that it's like in fashion, you have a color of the year, and this year is brown, and we pack, and then next year we all dress green and spread, so we pack and spread. So it never converged to an actual policy, but I wanted to mention it because it's how it started, pack or spread. So yeah, the IBM employee had a clear idea that he wanted to pack, but then
someone else wants to spread. But in this case, is it really a matter of latency? In this case, for me, that's another property to the task. In this case, maybe they don't really care about running first. It's really about running on the same to take care of the topology.
Hi, so just about the pack and spread, we are actually using some Chrome OS, and it's for latency. And we call it prefer idle. So for our latency sensitive threads, because EAS likes to pack, if there is an idle core, we prefer to run on the idle core, and that makes a big difference for the latency. So for latency sensitive threads, I think that could help here as well, if it's labeled as latency sensitive.
Yeah. Yeah, I agree that in this case, that's what we want to achieve. When you have a deadline or whatever, then you decide which CPU is probably the best one. Either you can wait on the CPU for the current task to run, or you have to look for an idle CPU. That's really depends of the constraint. Yeah.
This prefer idle thing was actually the use case we had in mind in Android to drive this latency nice. And then it developed into something else. Yeah. But this implementation is still there.
No, I agree on that. It's just that, but I would say that the prefer idle, normally if you are able to set correctly what is your latency, and the scheduler know the state of all the CPU. Selecting an idle CPU should be the obvious choice, but that should not be, I want to be on an idle. That's meaning I have this 1 millisecond constraint, and the only way to reach this is to use an idle itself. So that's why using the prefer idle, it's the solution, but not the constraint for me. And we have to take care to not put a knop for each solution, but that should be better to have a way to describe your constraint, and then that can spread in CPU selection, in slice selection as well. That depends.
So you just essentially answered the question I wanted to say, to ask, or my remark was, I clearly recall this starting in 2017 by one request, and then every year the wagon got bigger. In 2020, the session was 8 different people. Yeah. So you just said we need to take sort of every possible need into account from a tactical point of view, but you do you know how to do this stuff. But I was saying maybe you want to say this and this and this is off topic, like pack and spread. No, this is not. You see what I mean? Like in order to drive at least one thing done, instead of saying, because what happened last time was that no, I want some of that, I want some of that, I want some of that, and maybe it's just, this is how you make good software, but maybe it's also how you never merge. I don't know.
Yeah.
Does Peter want to say something?
Yeah, Peter does. So one of the points here is that the user rarely knows the running time, but the software itself actually, it's fairly simple in these types of software that have a periodic setup to measure the running time. I mean, they keep doing the same thing over and over and over again. So take a reading of thread local clock or task local clock before and after, and you know how long it's been. And then you can do some statistics on that. On top of that, we have in the past, on several occasions, talked about SCED deadline falling back to CFS instead of hard throttling. So that might also be used for a number of these workloads.
Yeah. So the only thing is that being able to accurately measure the runtime, it's not that easy, I would say, when you have an interactive system on Android and so on. There are some parts which are quite easy, but the rendering of the display, for example, can vary quite a lot. At least that's what I mean. For discussing with case, I know that that's really something difficult to say. That will be the running time of my application or the display part of your application, because that's really depends what has to be done. So being really able to say the running time will be that for 99% of the time, it seems to be difficult on Android system.
But
right, exactly. But if you combine that with a fallback to CFS instead of the hard throttle that SCED deadline currently has, then you can be far more relaxed with your runtime and do maybe a 60 or 70%. And then whenever you do overrun, you don't get throttled, but you get lesser quality of service.
I mean, you have a guaranteed part, and you can sleep lower, let's say, to CFS.
That could be, but that would be the solution. That it still means that you need to define what we want right now.
Right. So this is one thing that I think you originally had in the deadline patches, and that we dropped in the simplification pass to get it all merged upstream.
Yes.
But it shouldn't be that hard to reintroduce. I mean, if people think this will actually work for them, this should be fairly straightforward to add.
Okay, that's good to know.
How well will it work for affinities? Or did you fix the affinity thing?
Yeah, Daniel had.
Right, Daniel.
Yeah, I think in the mid-term, there are ways to get out of the affinity, of having affinity on deadline tasks. There is the idea of the the semi-partition. There are ideas using some time of dynamically partitioning with load balancing. It seems that that the goal is the same partition will allow us to do that, but we can take some shortcuts and do some kind of load balancing with partition. That's something that we can do for the deadline.
I also just want to bring back talking about preferred idle. If you always do a prefer idle, but the idle processor goes sleep for a long time, that could be a very long wake up. So actually, it kind of defeats the purpose of a latency sensitive task. Is there a preferred recently idle?
Yeah, that's why I'm mentioning that for me the prefer idle that can't really be an interface for the user, because that should be that's a way to achieve a latency. I want this latency, and if it's 1 millisecond and the CPU is in deep cluster down state, you will not be able to reach the one millisecond deadline. So,
yeah, I was going to add to this latency of the CPU wake up and some other devices. So this is the talk that we will talk tomorrow with Rafael. Why don't we have this kind of a flag per task that we can actually specify the need of the system, that you shouldn't go into deeper idle states. You will be wake up soon, and that task will actually run.
You mean per task?
Per task, yes.
That could be, so there are several things, but for me, so in the current proposal, we use the runtime field of the set scheduler thing. So the runtime part of the deadline scheduler we're working, but maybe the deadline field is more appropriate for us for things like that. If you're able to say my deadline when I will wake up is this amount, that could be an easier way to select or to prevent, either select a CPU in a shallow state or prevent some CPU to go in the deeper state. But at the same, that's always the same, that the end result is that. But the task will never say, I want a shallow C state, because that from one platform to another one, the shallow C state can be 1 microsecond or 1 nanosecond or whatever, and the deep state can be 1 millisecond, 10 milliseconds, that really depends. So we need a way to do that. So this is just a short recap of what we did on the latency nice. So yes, this doesn't apply anymore. The goal was to have some priority ordering, relative priority. So I want to run before some other things, without any meaning in terms of running time, of latency, and so on. And we were using a sign value just as a way to say, I'm latency sensitive, or at the opposite. I would say, I don't want to be scheduled first. I want to have a long slice. So yeah, that was either to run first whenever or to minimize the overhead and the preemption. And the goal was really to not break the fairness. And I think that's something we need to keep in mind. I mean, all this scheduling class, it's about fair of the CPU runtime. And if we start to break that for some latency things, then that will be difficult to move forward on that. We'll probably move a bit. So the new EVDF way of working. So the proposal is to use the slice duration to order the task. So I have done some experiments in the past few days. So we need to remove the no respect slice in the sketch feature. So in order to be able to preempt the current running task. The slice, in fact, is used to define the deadline of your task, and the deadline is a way for you to run before the other one. So with the shorter slice, your deadline for another task waking up at the same time will be before, and you will run first. That's really the thing. So once you're eligible, you will run first, but on the other side, you will get preempted also earlier. So you will have a short slice, but then if you miss to do all the things in this slice, you will have to wait for more things. So we have to be careful about how to define this how to monitor the running duration and how to define the slice. On the other side, setting a longer slice when you don't want to be preempted, it's quite easy. I don't know how long we can go, but I would say that it's just that ask the longer slice that you want. So you will run after the other one, but you should have a longer way to do that. And if you only have tasks with long slice, then you will minimize the number of preemptions. So for this part, I would say for the I don't want to be preempted part, it's quite easy with the slice because you don't have any deadline to fit too much. So so I did a simple trial there. So with 2 tasks, one is running for 4 milliseconds, the other one is running 1 millisecond. So I think that, yeah. On the top, it's just I'm just using the default. So we can see that sometimes you have to delay, other time you can preempt the current one, even if you're short one. And I would say that's pretty depend of the lag and how it's going on. So it's just that you can accumulate some lag that you will run before. It's a periodic pattern. I mean, you can see that all the time. I just show some three wake up and running, but that happen all the time. And on the bottom part, I have reduced the slide of this short task, and effectively, you run first. So it's a 1 millisecond running task, and I set the slice to 1.1. So I take this 10% margin. So for that, I would say it's okay. But the virtual time that is used in EVDF doesn't scale with the DVFS for the first things. It's an absolute running time. It also doesn't scale when you are running on a heterogeneous system. If you're running on a big or little, your runtime will be different for the same amount of work. It doesn't take into account the SMT. I mean, if you have something else running on the other thread of your core, that will slow down your activity. And also all the cache miss and the CPU architecture. And we know that at least on ARM system that for the same job, we know that some core are much more efficient than others. Or I would say, if you have some CPU intensive task and you are using what we call the big core, you are pretty efficient. But if you're doing some IO work or you have a lot of memory access, you will not be that much more efficient than a little core, which means that you can't really say that always be 1 millisecond. This 1 millisecond can remain 1 millisecond on the little, but can increase. It's quite difficult. That's why I was saying that it's quite difficult to define a runtime in our case. Yep.
So
maybe.
Yeah, so one, it just needs to be good enough, and statistics will more or less average it out. On the other hand, Ricardo Neri was also proposing these classes with different scale values between the heterogeneous systems for some of the Intel systems. And I think that same class system can be applied to some of the ARM systems. Like you say, simple integer workloads might scale a lot better than floating point or SIMD workloads between the heterogeneous systems. So you can have different scale values. As to the DVFS, I think we've hit that before with SCAD deadline. And there were thoughts of adding another clock. So currently we use what is it, thread clock, but we could expose the DVFS normalized clock that we use inside of the scheduler to the clock subsystem, so that tasks could use that to measure themselves. But I don't think we ever actually did any work on that, just a proposal. But yeah, that's an actual issue, the DVFS thing. That is more broadly applicable than just this topic.
So yeah, scaling the virtual time can be aware. The other point is that how this impact, I mean, in the EVDF, we have this max latency the max duration before being scheduled, the max how this will impact all of this. I mean, my understanding of the EVDF, the goal is that we can cap the maximum waiting time of a task depending on the slice and so on. How this will impact? Can't we be in a situation where we are increasing in a non-usable way the maximum delay before being scheduled in this case? That's another thing, because if you start to scale your clock with the CPU, your clock will move forward really slowly. So you can be stuck with one task and you will have to wait milliseconds, I don't know. I mean, that's something we have to fix, to check at least, that we don't end up running 10 milliseconds, 20 milliseconds before going to the next task as well.
Yes, but for measuring workload, like you said, currently we measure wall time, but DVFS can have the system at half frequency, and then we measure double time.
Yeah.
So that can be normalized. The other issue is more tricky, but yeah, EVDF is a fully weight-based scheduler, and if you pile on more tasks, you get to wait longer. That's how it is with shared time schedulers.
Yeah, these are all the things that we need to fix for sure before. So here in this case, I'm just showing what I was mentioning is that it's exactly the same task. On the top, it's running on the big core. So even that, I need to check, but it's probably because, it has exhausted this time, but that's really mainly the way that we are preempting. But then on the other way, we have this situation. And so maybe that's something we can be fixed. But I was surprised that in this case, we also have to wait for more than a tick. I was expecting to be rescheduled even before, but it looks like you have to wait. If you miss to do everything in your slice, the penalty will be even worse because you will have to wait for the end of the slice of the auto task.
Yeah, then you have to wait a full super period again. That's correct. That's painful. So one of the things that we have in EAS already is the capacity numbers between, or the relative capacity between cores.
Yes.
So we could scale up the slice request in the inverse proportion so that slower cores get a slightly larger slice request or something like that.
Okay. Yeah, that might be, yeah. And then even if we set a slice, what if we have two tasks? Because at the end, if we decide, if we are able to know the duration of your task, and we ask user space to set your slice. When you have two tasks with the same slice, that doesn't mean we can still have one task that we want to run first. So we need, it's not enough that we still have a degree of selection that we need to do. So that's my point. It's just that setting a duration, right now, I don't see that or setting a slice because it's not your duration. For me, it's not enough to cover all the cases that we want. And the other part is that what the slice duration mean outside EVDF. I mean, we were speaking about selecting a CPU, we were speaking about, I don't know, maybe selecting the frequency of the CPU or whatsoever. I mean, the slice duration in this case, it's quite difficult to translate that it's something else than the EVDF slice value.
Yeah, almost. So it really is a slice request, and there are other scheduling algorithms where you can do similar things. It's just EVDF is somewhat nice. And it's already defined as a hint. I mean, the trivial example would be to track the minimum shared slice across all tasks on the run queue and then just use that. I mean, that works for every scheduling policy, even the trivial ones. And then, for example, if you only have long sliced tasks, you'll get long slices.
Yeah.
EVDF can just nicely mix the slice length. Yeah, so what if two tasks have the same slice but need a different priority? I don't know. I mean, we still have to wait, but yeah, priority is tricky. I mean, at some point you'll just have to start using deadline more, I suppose.
So, yeah, so, sorry, just what was the...
I was just gonna add to the previous, in our cases, we need some threads to have long slice, but also latency sensitive. So right now, if we strictly use the nice value with EEVDF, you can get that because the nice value will adjust the deadline. It's ordered by deadline. Plus, it will give you a little bit. It'll give you the same slice as everything else, right? So you can potentially run faster. Eligibility makes it a little bit harder, but so having a different abstraction for latency seems like it will be useful.
Okay.
Rafael,
so my comment went in the same direction a bit. And the other is that this needs to be scale invariant as long as we have heterogeneous systems, because otherwise I don't see how we can migrate things and still do the right thing after that. So yeah. Also, it's quite unrealistic to expect that somebody will adjust their own slice. This should be done probably somehow automatically based on the runtime measurements that Peter mentioned before.
Yes, but yeah, so user space applications should do this because the kernel does not know when the work starts and when it ends. I mean, it just sees job activations, but things like log contention and IO and everything else will muddy up that view that we have in the scheduler. But with user space can very easily add the start and stop of their work thing and then provide that information to the kernel. So yeah, but a user space will need to change left either which way around, whatever kind of hints we will add. So yeah, I don't see a problem with that.
Just one point here that we go back and forth on the deadline because of the runtime is the thing that pushes us to think on the. But I think that the runtime of the two things, they differ a lot in the sense that on the deadline, we need to account to the pessimism and that's it. So that's a facility that it's easier to think on the worst. And then we add pessimism because these relax the task model that we can use it there and we can do our mathematics on it. Here on the VDF, it's the runtime, it varies so much and that's why I think that DVDF is the way for this task, because then you can start trying using some sort of statistics and try to figure out the value with all those variables like the VFS and so on. But one thing that I see in common is that we don't have a way to notify to the scheduler when a cycle ends from the task. Like when doing research, I always try to figure this out from outside, like, okay, when the task goes to sleep on the S state, not on D state, then I can try to argue that is the end of the period, or the end of the cycle. Let's not use the end of the cycle of the tool. That might not be periodic, so let's not use the word period, the cycle. So trying to figure out the cycle without a hint from the user space, it's difficult.
Yeah, you can't do that. You need help.
Yeah, if there would be a way, let's say, if I ask for a person that I know that understands the interface well better than I do and has more power on it, if there would be a way to give it to the user space, a path to give this hint to say, okay, this is my cycle, this is my cycle, this is my cycle. That, sorry?
Scheduled.
Mm-hmm. Scheduled, yeah. If there was a way to tell that, but the problem is that if you do scheduled, yeah, the scheduled without blocking, right? Because you don't want to block. Like on scheduled deadline, we block on scheduled.
Yeah, but again,
On the CFS, you might not block.
Currently, yes, but you can use that thing to just signal that you are finished, and then you can apply different policies to the.
Yeah. Because now we go to sleep on the yield. If we don't go to sleep, because most application doesn't sleep on time or doesn't like scheduled, doesn't schedule. They sleep on waiting for something. If we could use scheduled as a hint.
Yeah, no, schedule doesn't schedule out. I mean, schedule just it doesn't take you off the scheduler. It just sends
for the real humans, for the scheduled line, it sleeps. So that's why scheduled could be a thing. Yeah, for the CFS.
On scheduled deadline, it's actually sleeps when you do a schedule.
But that's why it's way better to think on these things on the VDF. Like if we could use scheduled to say, okay, this is the end of my cycle, this is the end of my cycle, it would be easier for the heuristics inside of the kernel to know, okay, this is this slice on this CPU, this is the slice on that CPU.
But could you use it then for?
So I think we should definitely look at adding a hints-based interface to say this, but I don't think scheduled is the answer. If you look at random existing user space, it calls scheduled in random and expects random things. It's just never going to work for this. There's too much garbage out there that uses scheduled for random things.
So that's why I was asking Peter a new interface.
Scheduled too.
But even that, I mean, the point for me is that having the slice and the duration, I think it's not enough to describe the CFS task. That's my point. Probably that's the first starting point. And maybe using the deadline interface to set a deadline, a runtime, so a slice and a period is a way to characterize your task. And this can be used in the EVDF to do some better or some smarter decision.
Yeah, the point is that
I agree that it is not enough. And yeah, it's just one step. We can look at making things more complicated, but we first need to make sure that the scheduling algorithm stays sane if you add more bits on. Solving a multi-dimensional programming optimization query in runtime is just painful. But yeah, we can certainly look at that, see if how we would use a deadline hint. But that's a deadline in real time. And real time slows down in virtual time the more tasks you pile on it. But yeah, we can investigate, see what falls out. As to the hints, I would propose a new system call, but not reuse the yield name. Maybe scat hint with some flags or what have we. But yeah, we can look at that.
Yeah, I'm Enrico Bini from, they do scheduling theory. So, most of the things I understand, say 50%, but so maybe I share, a bit of something that is in scheduling theory, which maybe help if I got the idea. So something that, for example, with EDF, plain EDF works, and we often use it, is the setting what is called pseudo deadline, where pseudo deadline is the deadline used to schedule, while the real deadline you want to meet is another deadline. So every task has two parameters, one which you use to schedule, and the other one is the real deadline you want to meet. So, if I understand, and I don't understand implementation of EVDF, but I know the paper, maybe, and it's a big maybe, one could use the virtual deadline to do, I think you use virtual deadline and you recompute the next virtual deadline at the time of the virtual deadline, I guess. But then you may use the virtual deadline plus minus something to decide the priority of the task. Maybe those which needs the more responsiveness, you just decrease the virtual deadline, but you recompute it at the correct time later. And then another, if I can just, so that's something. It's, there are plenty of references here. And another comment I wanted to make is that when you said you may have a task requiring non-preemptiveness, so those which need to run for long. So I'm wondering if you guys, by you guys, I mean that, you guys write the code and you know what you do. If you ever thought of trying to put on the same core tasks which require the same time granularity. By time granularity, I think I mean what you are called a slice, I guess. Because I think it does not make much sense to have on the same core a task requiring a long granularity together with a task with a small granularity, because the task with a small granularity will, of course, have shorter deadline, and then it will preempt the other. So if the other wants to have no preemption, it's very unfortunate. So I think grouping task and maybe assigning to core depending on sort of shades of time granularity. So the ones with small granularity together, then on, maybe it's a good something. Anyway, yes, yeah.
So yes,
sorry, Peter, Vincent, you had to choose because you also have the next slot. I'll just start the timer for the next one. Then you choose when you say, okay, we stop this, we go to the next one. Just say this. Peter, go ahead.
Yeah.
Maybe just a few more minutes.
I've been telling people to not mix long slice and short slice tasks if they require the non-preempt thing. But that was more a manual thing. We can certainly look at improving the load balancer to try and differentiate between these things. That makes sense.
What about the, if we design something like this as complicated with all those things, what's the benchmark for it, right? Like we tested, in our group, we tested the latency nice and this slice length thing with a common Android workload, and we don't see any difference. So, if you make this system more complicated, the Chromium guys said they clearly profit from prefer idle, and they might profit also from other things, but designing something complicated without a benchmark.
A monster. Chrome is a beast, and they know this.
Exactly.
But they're not fixing it. So Chrome has this main event loop that is very, very long. So shorter slices will do nothing for them. But the way we're testing this is running cyclic tests. So you run stuff with like hackbands or other stuff in the background, and then you cyclic test with a shorter slice, and then see if the latency is improved. That's one way of testing it.
So I did, usually I'm using Hackbench and cyclic test as a unitary test. I also, with the latency nice, the previous one, I did some, there is this ping pong ball on the screen, and the benefit was obvious, really obvious with this. It was really clear that the latency nice was giving benefit. The only thing is that in addition to using latency nice, I have also split in C group all the pipeline. Right now I have some more C group to say this is the pipe. I put all the process involved in pipeline in a C group with a low latency, with a negative latency nice value, in order that all the tasks involved in the display pipeline was scheduled in priority. So whatever the solution we will use, we need to use everything available for the scheduler. So the C group is one thing that is probably not used enough. The latency nice, but I agree that just not latency, whatever this latency int or latency interface, this need to be used in the right way. And I agree that it's not as obvious as just enabling that for some tasks.
Yep. The standardized use case or benchmark is part of the solution, right? So that people can discuss the results. Otherwise, we end up in designing something very complicated, but in those rich systems, you don't see an effect at all.
Yeah, but that also means maybe they will need to adapt their interface, their way their application are communicating with the the kernel and the scheduler. Yeah. So I think it's time to move to the next.
Yeah.